We would like to welcome our speaker, Mr. Swaroop. So Swaroop is a principal engineer R&D SW and MSO artificial intelligence engineer at WS Audiology. Swaroop would be giving an interactive talk session on AI-driven smart triage, lag, MCP in action. To know more about Swaroop, you can check the below link. So Swaroop, it's over to you now. I can stop the screen.
Swaroop, you are on mute.
Yeah, thank you, Komal. Let me bring up my screen.
Yeah.
Hope the screen is up.
Yes, it's
Yes, we
visible.
can see. But we lost now.
Swaroop, we are unable to see your screen. Can you please share again and start?
Okay, can you see the screen now?
Yeah.
Yes.
Okay.
Do you see the presentation?
Yes.
Okay, good. Good afternoon, everyone. Today I'm excited to share with you all an AI-driven solution that is transforming how we approach our diagnostic triage in our organization. So we are calling it a Smart Triage, and it combines RAG plus MCP, which is a model context protocol. It dramatically enhances our diagnostic accuracy and efficiency. So this presentation will show you how we are using our artificial intelligence not to replace the talented engineers, but actually having them a good capability and amplifying their capabilities, right? So you can picture a use case where it says there is a production crash happened and it is 3 a.m., right? And then you are sleeping and a production crash has happened and thousands of users are getting affected. And we are constantly jumping between our Firebase crash logs, Git, Slack. And 4 hours later, we found out that it's an external bug that has causing our issue. Does it sound familiar? And who has spent more than 2 hours of debugging just to find out who owns the crash? That might end today. So I'm Swaroop. I'm a product architect at WS Audiology, specializing in Android applications, particularly in hearing aid controller systems. So my work focuses on building robust, user-friendly architectures while ensuring high performance and production stability across various operating conditions. Recently, I've been integrating AI-augmented engineering practices into our workflows, and Smart Triage is one of the most impactful initiatives. My role as a product architect basically means that I get to deal with everything, from the mobile apps to the SDKs to the embedded software, because I'm coming from a hearing aid world. So this is where my expertise and then my tech stack lies in. And sometimes I'm trying to debug things that does not exist anymore, but it is still breaking. Because I work across all these layers, I have seen how a tiny issue can start inside the app. It mysteriously teleports to the SDK, bounces off from a different layer, and finally it lands on the hardware guy. And the hardware team then says that it's not us, it's your thing again. So that thing comes back to me again. So I have truly felt this pain of a triaging system. And then this entire cross-layer adventure has shown me one constant challenge, which is triaging. So what is the current problem we have and the challenges we are facing with the current triaging system? Before we talk about solutions, let's acknowledge the real problem we are all suffering through. Triaging today is manual and repetitive, and honestly, a bit of a patience test. Most of the time, we are switching between 5 to 10 different tools just to understand a single crash, right? And then we are looking at any issue or maybe crash issue. Sentry is one of the tools which we are using for our crash monitoring. So we are looking at Sentry, we are looking at logs, we are looking at the repositories, we are looking at tickets, we are looking at the documentations, and you name it. By the time we finish gathering all this context, we already need a coffee break. And because our teams are spread across the time zones, something as simple as an investigating an issue might need an input from the other team, which sits 12 hours ahead of you. Then the conversation will go something like this. Hey, is this yours? Then they might say, well, we'll check in the morning, and then boom, and then 24 hours is gone during the triaging time. Then there is a knowledge dependency factor that comes into picture when there is some special person who magically knows how every other subsystem will talk to every other subsystem in your system. If that person goes on a vacation, then the triaging time just does not increase, it doubles. It also gets inconsistent and inefficient because junior engineers might miss some patterns that senior engineers would spot immediately. It is not their fault because the triaging system lies heavily on the human intuition. And also there is a duplication issues as well. The issues that we already seen before and the issues that already we have fixed before. If we don't have a knowledge of the past history, this becomes inefficient because we might end up picking the same issues again and again. To give you a sense of the scale we are talking about here, the average triaging time we do today along with the investigation is approximately 2 to 4 hours per issue. With smart triaging approaches like RAG plus MCP, we have seen it drop to 10 to 20 minutes or maybe 15 to 30 minutes. That's the gap we are trying to close, right? So we are trying to do a use case thing where we have seen a triaging system, which is happening on a traditional triaging system. So in the last 6 months, we and our team have triaged around 300 issues, out of which 110 goes to the SDK team and 85 goes to the app team, et cetera, et cetera. And then if we calculate it roughly, it is a whooping 667 hours, which is close to 83 days and 4 months of time, right? This can be dramatically reduced because this is not what engineers are signed up to do, right? So we can enable engineers so that we can triage the issues faster so that they can focus that time on solving the real problems, not actually finding where the problem is, right? So with smart triage, we're estimating that it would be around 25 hours. And there is an additional wastage of time here, which I'm talking about is about the misrouted tickets, which is like we are giving a ticket to a different team. Then they start investigating and coming back and saying that this is not our issue. Then we need to start our investigation again. And there is a duplicate analysis wastage as well, which is, so the issue is already, we have seen it in the past, but we don't know because that person goes on a vacation. So we have picked up that duplicate issue and then we are trying to investigate it again. That we are trying to solve it today. So let me walk you through our system end to end because this is where triaging can get quickly complicated because we are coming from a hearing aid world. This is our layers stack. Everything would start with the mobile app at the top. This is the main user's touch point and usually the first place an issue is observed. The app communicates with two major components, which is the SDK layer and a WSA cloud. The SDK layer handles all the device-side logic, and the WSA cloud manages the configuration, syncs, profile updates, feature data, and all the remote interactions. From our SDK side, the flow still continues into the embedded software layer, which is again another layer, another team. This is the layer that understands Bluetooth protocols, command executions, and device-side logic. Finally, the embedded software talks to the actual hearing aids. So here is an important insight you might need to know. Each of these layers is a potential failure point. So when the user says, my device disconnected, we suddenly have multiple possible origins. For example, a Bluetooth timeout can be caused by a app connection manager, a SDK's Bluetooth handling failure, or the embedded software's state machine failure, or the device firmware or hardware failure. All these produce the same symptom for the user. This is where an AI-assisted context-aware triaging systems becomes incredibly valuable. So let's talk about what the solution is. It's an AI-based solution which consists of RAG plus MCP. We call it a smart triage. So what exactly do I mean when I say a smart triage? At its core, it's an AI-driven analysis system that serves as an intelligent assistant for our engineers. Think of it as having a senior engineer on your team who understands everything, who supposed reads every single document, remembers every single crash that we have ever had, knows the entire code base, and most importantly, never sleeps. This is essentially what Smart Triage is. Here is what it actually does. First, it looks at multiple data sources together, the crash, stack trace, the log patterns, the code snippets, configuration states, and merges them into one unified understanding. Something we humans can do, but not at this speed and scale. Next, it predicts the ownership. In our early tests, we are seeing about 85% accuracy on our systems on whether the issue belongs to a particular team. It's an app team or SDK team, e-software or cloud or device. This alone saves hours of ping-ponging between the teams. But it doesn't just point fingers, it gives reasoning too. Instead of just saying SDK issue, it explains why. Maybe a null pointer, something like maybe a null pointer coming from a specific config or an unstable Bluetooth callback sequence. It also gives you next steps as well. It might say check BLE connection timeout on configuration manager, a particular line as well. This is basically giving engineers a head start, like skipping to the right chapter in the right book. It also surfaces past incidents. Something like this looks similar to a ticket WSA 1234, which is from 2 hours ago, from 2 months ago, I mean. Something even senior engineers may not recall instantly. And perhaps the most magical part of it is it can scan millions and millions lines of code and narrow down the search to just maybe 3 or 4 files. Huge systems suddenly feel small and manageable. And the key point here is to, again, stressing the point, it is not replacing the engineers. Human intervention is mandatory in these systems because these are not fully matured, still not accurate. It only amplifies them. It takes away the slow and painful process of investigating and triaging, and it leaves the engineers to focus on solving exactly the problems they need to look at and solve. So as I said before, we have the smart triaging system that is composed of RAG plus MCP, right? So what is RAG? You might be wondering why RAG, right? A RAG is a knowledge-based system that we use in our system. So you might be wondering why RAG. So why not just use a large language model on its own? Let's understand why we need to use RAG, because to simply understand it, RAG is giving your AI a library card to your entire knowledge base. So without RAG, AI is basically guessing, but with RAG, you have a reference to your actual documentation, logs, architecture, and history before answering. Here is what RAG pulls from our system. So if you see the knowledge base, the architecture docs, how your system is designed, how the components interact, etc. It has knowledge base to your release notes, known issues, breaking changes, feature behavior, etc. It has guides to your protocol guides as well. This is where it understands how the communication is happening between the subsystems. And it has an issue to known issue repositories as well. Patterns we have seen before, all the known issues we have that will that will provide it to the RAG system. And then it has historic data as well. It has pattern data sets, and it has a Git history. Git history is exactly what changed, when changed, and why changed, right? So with RAG, there are no more hallucinations. We have citations instead. So instead of hallucinating, RAG makes the AI cite its sources. When the AI says this looks like a BLE connection issue, it can point to a specific documentation or a past ticket that supports its conclusion. This builds trust with engineers because they can verify the AI reasoning. RAG transforms the AI from black box into a transparent, verifiable assistant. This is why RAG is the foundation of the Smart Triage. It gives AI the context that it will never learn on its own. And one side is the RAG, the other side is the big player, which is the MCP. Let's discuss why we need MCP in our Smart Triage. At the core principle, MCP enables the AI to fetch what it needs. While RAG provides the knowledge base, MCP provides the tools to extract the right knowledge in a right way. Now, RAG gives AI knowledge, but it still cannot do anything on its own. This is where MCP comes in. If RAG is a library card, MCP is actually giving hands to fetch the knowledge. Here is how it works. So we have, as I said before, the entire conversation that started with the crash, right? So we need to pull the crash logs from somewhere. Sentry is our crash monitoring tool. So Sentry has provided an MCP server of its own. So we have integrated MCP server into our smart triaging system. The Sentry allows the AI, Sentry MCP allows the AI to directly pull the crash logs, stack traces, and breadcrumbs without you even having to copy paste everything into the AI workspace. It pulls whatever it needs automatically. And then we have Azure DevOps MCP. This reads ticket histories, comments, linked issues, and ownership patterns instantly. It helps the AI understand context and relationship between the issues. And we also integrated Git MCP. This is particularly powerful because now AI can explore the repository, search code, read files, and even check recent commits and blame history. If it suspects the recent code change has caused an issue, it can verify that hypothesis immediately. And we have a logs MCP. We can correlate app logs, SDK logs, and then the Bluetooth stack traces, embedded logs, everything side by side. This is critical because issues often span in multiple layers. The beauty of MCP is that it turns the AI from passive analyzer into an active investigator that can gather its own evidence. While RAG is a knowledge base, MCP provides the tools to extract the right knowledge in a right way. Now imagine this scenario. We have a crash to investigate. So all you need to do is to paste that crash ID into your AI workspace. And within 10 seconds, your AI fetches the full crash stack trace from Sentry, pulls all the related Azure DevOps tickets, identifies recent commits touching that area of code, retrieves relevant SDK debug logs. Suddenly, investigation that normally takes hours become a 10-second automated workflow. This is truly the power of combining RAG plus MCP. Yeah, let's look at how Smart Triage actually works end to end. This is where MCP and RAG come together in a unified flow. As a step one, we'll do something called signal collection. When the user reports an issue, it enters into a smart triaging system. Immediately, the system activates its MCP servers and gathers all the relevant signals. It's not just the data, it gathers the relevant signals. It pulls the crash track trace to understand what broke, gets SDK logs plus embedded logs to see what's happening at the device level, Azure DevOps to check the similar tickets if exist, reviews recent user actions to understand what user was doing before the crash happened. All of this happens automatically in the background. The engineer doesn't have to manually hunt through different systems. Smart Triage does it for them. This alone replaces 20 to 30 minutes of manual digging. As a step 2, when the signals are collected, we move to a knowledge retrieval using RAG. The system takes the crash information and searches through our knowledge database for relevant code context. It might find something like this. SDK version 231 has a known BLE timeout issue. The crash matches a pattern we have seen 3 months ago. The e-software team has already flagged a timing instability in previous builds. This is where the intelligence really shines. By combining real-time data with MCP and historical knowledge from RAG, the Smart Triage builds a complete picture of the problem. Step 3 would be reasoning. This is where a decision is made. The AI takes all the signals from MCP and all the knowledge from RAG, and then it synthesizes them into analysis. In a typical example, it might conclude saying that issue likely to be in the SDK layer, specifically in Bluetooth Connection Manager, and with a confidence of 87%. But it doesn't stop there. It also surfaces past incidents because there are 3 matching tickets, all were previously owned by the SDK team. This is where the confidence of 87% is coming. This gives the engineer immediate confidence that they are on the right track and shows that this isn't a problem that is novel. It has a precedent and a path forward. As a step 4, it also recommends the actionable steps. These are not just generic hints. These are code specific, code focused, and backed by real evidence. And the real payoff is what normally takes 3 hours of digging logs, checking tickets, asking teams, reading code. Now it just takes 20 minutes. This is what happens when RAG gives AI knowledge and MCP gives the ability to fetch exactly what it needs. Let's look at a small demo where we imagine how the system would work. When we have a crash log, it enters our triaging system. As one of the steps, it will do a signal collection. It looks at the Sentry, it looks at the logs MCP for any past logs. And then it looks at the Azure DevOps tickets to see any past tickets along with it. And it looks at Git MCP for any code changes that are related to the crash. And then it looks at the RAG documentation. Now, this is a step where it looks at the past knowledge and a knowledge base, a history of tickets, etc., etc. And also it looks at the protocol specs where any Bluetooth protocol was violated. And now it enters into a reasoning stage where it says we have applied a 0-shot classification where it classifies with confidence how much each layer has a role to play with this thing. And it also runs a similarity engine. And now it completes its analysis saying that 87% of time it can be an SDK issue. What actually took 2 to 4 hours before on a traditional system is now taking actually just 60 seconds. Earlier, we were hopping between 5 to 10 different tools. We are manually correlating all the logs, digging all the logs, searching for similar tickets, etc. It's all automated now. Earlier, we were guessing the ownership. Right now, AI is also guessing the ownership, but with evidence backed. So let's quickly talk about the architecture or the infrastructure which we have used. So at its core, we have MCP server setups. Which is we have Sentry for the crash logs, and we have Git MCP for the code navigation. Because without code, it is like we are doing a detective work, right? So we start with MCP, and then Sentry MCP will start it. We have started it there because it is with the crash analysis. It is the loudest and the painest problem we have ever faced. And then we try to add Git MCP because without code context, triage is basically detective work without clues. And then we started adding ADO, Azure DevOps tickets, and then logs MCP, which has give us complete 360 view. I can ensure that each MCP server setup is roughly takes around 2 to 4 hours or maybe less. So this is not a 6 months IT project. Then we have a RAG setup where we need a historical knowledge. So we have used sentence transformers. These are the models that can convert your sentence into dense numerical vectors called embeddings, which we can store it into the vector database. So these are battle tested. So your 500 document libraries should be just fine. So realistically, it's a weekend project. So I would recommend to start with a 20 to 30 high value documents, and then you can expand it later. So do not dump your entire Confluence on day one. Then we have AI model choice. So you can, this is a brain that interprets everything. So choices are Llama 3 we have. So this is great because it runs locally, it runs for free. You need not to connect internet for this model to work. You can have Mixtral, which is stronger for reasoning, but it needs a GPU on its side. GPT-4o Mini is great for your POC, but it is it comes with a cost. There is a subscription you need to take, monthly subscription. So what our suggestion is you can start with GPT-4o Mini as a POC. When everyone is impressed in your team, you can then move it to local and then run it locally using Llama 3. Infrastructure, very good news is that you can run the entire thing on a decent laptop. Any laptop that has 16 gigs of RAM should just work fine. M2, M3 MacBooks are perfect for this setting. And if you look at the privacy angle, if your organization fears that your data is leaving the building, this setup runs 100% locally. So finally, engineers get actionable triaging summary, ownership suggestions, root cause hypothesis, relevant files and commits, and then recommended next steps. This architecture is modular. So we can start something as simple as one MCP server, 20 documents, and then grow into a full triaging system in a phased manner. So as I explained before, the same adoption strategy you can take. You can start slow, you can prove the value, and then scale up. So you can also connect your system with Slack or Teams chatbot so that your team members can directly interact with the Slack bot on a Slack or Teams chatbot on an interactive manner. So as a conclusion, let me wrap up with 3 takeaways, which is the AI-powered debugging. Smart Triage uses AI plus contextual data to drastically reduce debugging time and effort in complex systems. This system enables distributed teams to collaborate effectively, improving decision-making and product stability. Issues get routed to the right team faster, and knowledge sharing becomes automatic. Smart Triage empowers new engineers by leveraging past issue memory and intelligent classification of expert level triage. Junior engineers can now perform like senior engineers because the system gives them the context and the guidance they need. This is the future of AI augmented engineering, not replacing engineers, but making them very more effective. Thank you for your attention. I open if there are any more questions on it. Thank you.
So wonderful, Swaroop. A quick question from my side.
Yeah.
When we talk about designing, and you said it basically, can you give us an insight? Like, is it, you said weekend job, or maybe it's a long-term thing? That how much time did you take design this entire thing?
So we have not fully done the entire system, Aditya. So we have started as a small POC. So it took us around a week to get to our bits and pieces of it. So it's not a big project that we have done, but to get to a state where we paste one crash ID into it, and then it looks at small sets of document we have, and then get to that. So it took 1 week. And then after 1 week, it might take a lot of time to scale up. But to get to a point where we can try out this one, it can be 1 week.
Awesome. Thank you so much. Yeah. Over to you guys, Deepti and Komal.
Yeah, we have one question.
Yep.
Deepak is asking 4 MCP servers, including logs, with hopefully hundreds of tools and their declaration, plus context from RAG. Aren't you facing any context bloat issues? How is the token cost or
Um,
price?
Yeah, that's true because we can limit. There are a few settings we can do at the large language model level to pick top K. So there are issues we have done saying that there's a lot of context that is flowing in. So we have tweaked that parameter to limit it to a top 3 or 4 suggestions that from each system would take.
Okay.
Yeah.
What did you face in?
Hi, Swaroop.
Yeah.
I have a question. So you have mentioned that there is no hallucination. So I think we have a comparison for ChatGPT and the perplexity. So when we are ensuring that when we have ingested few documents to RAG and to consider the same documents to retrieve the information. So how you
Mhm.
are ensuring that the proper document is, taking the reference from that when an issue is found or when you
So
issue is the trigger.
yeah. So what we are doing is here is we are trying to base our from smart triaging system to be on exact facts of our historical data. So we don't want anything uh, apart. We don't want the LLM to think beyond our knowledge base, right? So we have lowered the temperature level so that it just grounds on the data we have provided to it, our past historical data, our history of the knowledge history and knowledge base, our architecture documents, etc. So it should not go beyond the scope. So we are okay saying that the smart triage, I have no data, I can't infer this data, that is fine. So we don't want it to think and reason more than what it knows from its own knowledge base.
Okay, yeah. Thanks for it.
Yeah.
Thank you, Swaroop.
Uh,
Komal, can you please bring up the
yeah,
slide?
yeah. So thanks a lot, Swaroop, for a wonderful session.